Hi, welcome. In this video, we will solve problem find minimum in rotated sorted array asked by companies like Amazon, Microsoft, Facebook, and Google.
Now let's check out one of the most important problem in binary search. Find minimum in a rotated sorted array. Yes, this is the most important. Even if you are trying any Leetcode problems, even in Geeks of Geeks, and even if you are learning DSA, right? In binary search, this is the most common problem and this is the must to solve a problem. Okay. Even in interviews, you can see these similar type of questions, you can get it directly, okay, without any change. So given a sorted rotated array, again we have already discussed what is sorted rotated array. Okay, so basically if there is an array, or suppose if I am creating one array, 1, 2, 3, 4, 5, 6, this is my array, right? This is a sorted array. This is sorted array, and if I rotate it from any point, like from 4, if I rotate it by two elements or 2 units, okay, how my rotation will be like, right? This 4 will come here, okay, and then 5, 6, 1, 2, 3, right? Something like this. So this is how it is the rotation, right? I have rotated from here, and now you can see now it is not sorted. Now it is sorted in different parts, right? This part is sorted, right? And this part is sorted, right? There is an intersection in part, right? So complete sorted, it's like you can see like this is your sorted, and if you are rotating, if you are making a sorted and rotated array, so sorted and rotated, this is sorted and rotated array. So now it will be something like this is your graph, and it is again starting from here, something like this. Okay, so this is all about sorted and rotated array. Now let's see. Now let's see the problem statement. What is the problem statement? So in sorted and rotated array, nums of unique elements. Again, we have only unique elements. There is no duplicate element. And what we need to do, we need to find the minimum element in this array. Minimum element in this array is the goal. So you must write an algorithm that runs in log n, right? So we have given sorted and rotated array. So this is even our thinking should be to give the answer in big of log n. Okay, so you can check out the examples. Example 1, we have this is an array, again sorted, this area is sorted, this area is sorted. Okay, so sorted and rotated array, right? This is the minimum element, right? 1 is the minimum element, is this one, that's why the output is 1. Again in this array, this is sorted, this area is sorted, and this area is sorted, and again here in the pivot element I can say this is the minimum element, 0 is the minimum element. Now let's see how we can solve this problem. Okay, so these are my arrays, this is my array that is given, and let me put this is my array and how we will solve it. So if I say about the approach 1, okay, if I talk about the approach 1, that will be you can solve it linearly, right? So one of the approach can be we can solve it linearly. What would be the time complexity? Time complexity will be big of n, okay, and that will be a very basic solution that you can simply check it is 4 is your negative element, minimum element or not, and 5 is your minimum element or not, 6 is minimum element or not. Basically you will linearly check each element, you will get to know the minimum element. Okay, again your interviewer might not impressed by your answer because we have given one sorted and rotated array, right? So in the array is sorted, right? We should always think that we can apply something as binary search, right? We can apply binary search here. So now let's see how we can apply binary search here. So if I simply work on how I can put the binary search here. So this is my array. Let me quickly put the indexes 0, 1, 2, 3, 4, 5, and here. Okay, we will discuss it later. Now, when I am applying binary search, what should be my first step? What should be my first step? Find the sorted region, right? Remember, you always do this. Find the sorted region. find the sorted region, because for binary search need to be apply, we can apply only in sorted region. So we always need to find the sorted region. So again, how we will apply it? So suppose I will take one L pointer, low pointer, high pointer, and I will get mid. Okay. So 5 plus 0, it will give me this as in mid, right? This will be my mid. Now I have two regions, right? So I have this one region, right? And one region is from again here to this, right? Again, one region is sorted, right? You can see this is sorted region. Okay. This is sorted and this is not sorted. This is not sorted. And here also, like if I quickly put the indexes here, 0, 1, 2, 3, 4, 5, 6, 7. And if this is my low pointer, this is my high pointer, 0 plus 7 by 2. How to calculate mid? Basically, your mid will be your low pointer plus high pointer by 2. Okay. 0 plus 7 by 2, it will be around here. This will be your mid. Again, now it will divide into two parts. Okay. These are two parts. And now you can see this is not, the first region is not sorted here. And the second region will be sorted. Okay. Now there are two regions, right? Sorted region, not sorted region. Okay, tell me where your minimum element will lie. Where will be your minimum element? Where will be your minimum element? Okay. So this was my sorted array previously, right? What we did, we rotated it, right? And can I say I have rotated it from this point? I have rotated it from this point. Okay, so this is minimum because I have rotated from this point, right? This is my rotation, right? From here I have rotated. Okay, and that's why it is becoming not sorted. This is why unsorted region. Okay, so okay, let's go step by step. So how my minimum element will come in a rotated and sorted array. Okay, I am talking about rotated and sorted array. Okay, sorted array. How my minimum element will come? How my minimum element come? My minimum element will come by rotation, right? And can I say, right? This is by rotation. This is rotated, so this is my minimum element, right? This is rotated here, so this is my minimum element, right? Here is the rotation, right? Again, here is the rotation, right? If you can take other examples, let me check other examples. Like even here, right? This is the rotation point, this is the rotation point, and this is the minimum element. So can I say I am getting minimum in rotated and sorted array by the rotation? By the rotation, whenever there is a rotation, okay, here is a rotation, so I am getting this because this is the rotating point. This is the rotating point. Hence, here I am here the my minimum element is lying, right? So now my minimum is getting from the rotation, and from rotation always lie in unsorted region. Can I say that rotation is always lie in unsorted region? Right here you can see rotation always lie in an unsorted region. So from these things, can I say my minimum will always lie in unsorted region? Again, it will always lie whenever there is a rotated and sorted array. Okay, whenever there is a rotation, so it will always lie. It might be lie or like in the unsorted region. So can I say directly that it is always lie in unsorted region? No, it might lie in the unsorted region, most probably. Okay, but there are some chances. There are some chances that it can lie in sorted region also, right? So if I take one array, right here, this is completely sorted array, right? Here, this is completely sorted array. So this is the sorted array. So here, where is my minimum element? This is my minimum element. This is my minimum element, right? Okay. So even in rotated and sorted array, right, you can get the sorted array. You can get a complete sorted array, right? Because that is also a rotation by 0 units. That is also a rotation, right? So can I say then this will be my sorted region? This will be my complete sorted region, right? And if this is my sorted region, my minimum element is lying in the sorted region. Here my minimum element is lying in the sorted region. Let's check out this example. Here Okay, here if I am taking mid, right, this is my low pointer, this is my high pointer, right, this will be my mid. Okay, what will be the two regions? These will be my two regions. Again, is this region is sorted? Okay, so if I taking from one, this is not sorted. Okay, this is not sorted, but this is sorted. So my one is lying between both the regions, right? My one is lying in not sorted region, unsorted region, I will say, and it is also lying in sorted region. So there is also a possibility that your minimum element can be lie in sorted region, right? It is in the sorted region. Here it is in the sorted region. Even if I am taking an example, one array when there are only two elements, right? Like 1, 2, okay? Or even suppose it is rotated by one unit. So suppose 2, 1, right? Here also, here also can I say that this part is itself is a sorted, this part is itself is a sorted, right? Here also it will lie in, here my minimum element will lie in the sorted region, right? So when I take a single part it, and then I will say that this is the sorted part, this is the sorted part. So here also my minimum element may lie in the sorted region. So again, so when we say that about where your minimum element will lie, right? It will lie, it most of the time it will lie in unsorted region, right? But not always. There are few chances that minimum element can be lie in sorted region. Okay, and we have already checked it, right? So why it is lying on sorted region? Because there is a rotation. Because there is a rotation from that point. Whenever there is a rotation, okay, the rotation will always comes under unsorted region. Rotation will always comes under unsorted region, right? And that's why your minimum will lie in the unsorted region most of the time. But there can be cases when your minimum lie can be sorted region. This thing is clear. Is this thing is clear? Okay. So if I say, right, so that's the basic thing, right? How you will get to know about why there is a need of unsorted region, why unsorted region is building, right? If I to ask why there are two parts in these sorted and rotated array, right? Because we basically rotate from a pivot element, rotate from an element, and when we are rotating it, when we are rotating the sort will break into two parts, okay? Both the two parts separately will be sorted, right? If I taking the element, right, there will be one part that is unsorted, okay? If I'm taking with binary search, there will be one part that is unsorted and there will be one part that is sorted, okay? Now let's see how we will apply binary search, okay? Again, the goal will be again very clear, that always the first step will be find the sorted region, find the sorted region, okay? Now, so when I find it the sorted region 0, 1, 2, 3, 4, 5, let me write the indexes here as well. 5, 6, 7. These are my indexes. And if I take one pointer, let's suppose this is my low pointer, this is my high pointer. Again here, this is my low pointer, this is my high pointer. Okay. Now what I will do, let's try to solve this array first. Okay. So if I'm taking one low pointer is at 0, high pointer is at 5. Okay, what will be my mid? Again, how you will calculate mid? Low plus high by 2. Okay, so low plus high by 2, this will be your 0 plus 5 by 2. That will be a floor value of mid 2, right? Again, now I have two regions 4, 5, 6. Can I say this is sorted region, right? And from 6 to 3 I have one region, unsorted region. Okay, now this is sorted region, right? We got the sorted region, right? We got the sorted region. This is the sorted region. So first we will find the sorted region, right? How to find? Again, you can find it by simply comparing the first element and the mid, right? Your first element, if your first element is less than your mid or equal to mid, can I say that this will be your sorted region, right? We have checked this condition. This will be your sorted region, your first element here, right? 4 is less than your mid element 6, right? So this is my sorted region. Now, if this is the sorted region, can I say that let's use the property of sorted. If this is sorted region, can I say my first element is the minimum element in this region? This region, my minimum element will be the first element, because I am comparing, right? So suppose the array is sorted, right? Suppose the array is sorted, okay, like this. If the array is sorted, can I say that my minimum always lie in the first element? If this is sorted, if this region is sorted, yes. So what I will do, I will take one, I will store something answer, I will check, right? My low element, right? Is my low element, that is ARR of low, okay, is less than the answer, right? Whatever I have stored it, suppose in the starting I have stored it some infinity, okay. So what I will do, I will update my answer with AR of low, I will update with answer that is 4, and I will move. I will simply move that this part is done. This part is done. Okay, I will move. And how I will move? I will simply say my low will be mid plus 1. Okay, my low pointer will be here. Okay. Now again what I will do, I will find the mid. 3 and 5. What will be my mid? This will be my mid. Okay. Again, now if this is my mid, what I will do, I will again find the region, right? Can I say my this is the sorted region? This is the sorted region. And this is also sorted region. Right? This is also sorted region. Both the regions are sorted. So first of all, I will check the first region, right? And this is sorted region. Again, what I will do, I will take this element. I will take one. I will take one. And I will compare that is one is less than the my previous minimum element that I thought. I thought that this will be my answer, right? This will be my answer 4, but it is less than it. So what I will do, I will update 4 by 1. Now my element will be 1, and again I will move. Again I will move. I will say low is equal to mid plus 1. My low pointer will be here. Right? My low pointer will be here. Okay. Again I will compare between these two. So what will be my mid element? This will be my only mid element. This is my mid element. Again I will compare. Is 3 is less than 1? Is 3 is less than 1? No need to update. So what I will do after this, okay, after this, what I will do, again, this loop will break because eventually high will get a greater than low. And what you will get as the answer, you will get the minimum element as 1. So what are the steps? We are always finding the sorted region. If it is sorted region, how we are finding it? First element is less than equals to mid. And now if the second step is because it is sorted region, because it is sorted region, what I am doing, I'm simply moving, right? I'm taking the lowest element, right? I am taking the ARR of array low. I'm taking the low element, right? Comparing with my minimum, and I'm simply moving. I'm simply moving. Mid is equal to low, low is equal to mid plus 1. Sorry, low is equal to mid plus. Okay, now let's solve this problem. Okay, let's solve this problem also. Okay, let's see again. Okay, again what I will do, I have 2 pointers low and high. I will find the mid. How I will find the mid? I will take one low, one high pointer, low plus high by 2. So 0 plus 7 by 2, what I will get? I will get something around 3. Alright, floor value will be 3. Now again 2 region, one this region, right? One this region. Okay, again here what is it, is this region is sorted region? Is this region is sorted region? No, right? This is not sorted region. So which region is sorted? This region is sorted. Okay, this region is sorted. I will say that this region is unsorted. So again I will find for the sorted region. Find for the sorted region. And if I get it, like here I am getting sorted region, right? So can I say in this sorted region which is the lowest element? My mid element is the lowest element, right? I will compare between 9 because this is my sorted region, right? Mid to high, mid to high. mid too high. So if mid too high, which will be the lowest element? Your mid, right? So what I will do again, I will compare my mid element. I will compare my mid element here of mid with my minimum, right? And I will update it. I will update my minimum with my AR of mid. And once this is done, what I will do, I will update my high pointer. I will update my high pointer. High pointer is equals to here mid minus 1. So it will shift from here and it will come here. This will be your high pointer. Again now low and high, which will be your mid pointer. This will be your mid pointer. Again you will compare. This is your sorted region 7 to 8. And yes, this is sorted region. What I will do, again I will update. I will check here what is my minimum element. Minimum element was 2 here, right? Minimum element was 2 here, right? So what I will do, I will again compare. I will take, is my lowest element, this is my sorted region, is low 7, is less than 2, no it is not, so no need to update. What I will do, my L pointer will simply move. L will be mid plus 1, my L pointer will here, right? Now both the pointer, right? My L pointer is also here, my high pointer is also here, right? Where will be my mid? Mid will also be here, right? 1. Again I will compare. This is the only sorted region, this is the only sorted region, right? So 1 is the sorted region. I will compare, is 1 is less than 2? Yes it is. I will update my minimum. I will update my minimum with 1. So 1 with the region. Okay. So this is how you can solve this problem. Let's see one more example. Now let's see if the array is already sorted. Like here, if the array is already sorted, right? So how you can solve this question? So again, I will take one low pointer here. I will take high pointer here. 0 and 5, where will be my mid? Right here, my mid will be here. Right. Again, I will find the sorted region. Again, I will find the sorted region. 1, 2, 3. If this is sorted region, if this is sorted region, suppose my mid is with higher value, right? Plus infinity, right? So yes, this is the sorted region. This is the sorted region. What I will do, I will update my minimum with 1, right? My lowest element, and I will update low is equal to plus 1. My low will be 0.2. Again, I will find the mid element. Low is here, high is here, right? Mid element will be here. Again, I will find the sorted. This is the sorted region. 4 to 5. This is the sorted region. Yes, it is. Right. What I will do, I will take 4. I will compare. Is 4 is less than 1? No, it is not. Again, be 1. My minimum will be 1. Again, to this, what I will do, I will move my low pointer. Move my low pointer here. Mid plus 1. Low will be here. Right. Again, I will get the element. Where will be my mid? It will also be here. Right. Again, I am getting 6, and I am assuming that this is only my sorted region. This is the only part sorted region, right? I will compare. Is 6 is less than 1? Is 6 is less than 1? No. Need to update. So I'm getting again the minimum element as 1. Right. Now let's see. Now let's see this example. Here also I have low here, high here, mid will be here. This is not sorted region. This is sorted region, right? Again, if my minimum is with plus infinity, I will check. I will check this region. I will check my mid element, right? Because this is sorted, right? Mid too high, mid too high. So the lowest element will you will compare with mid, right? So you will update with 1. Okay. Again, after this, your high pointer will lie here. Again, 4 and 5, where will your mid, right? Your 0 and 1, your mid will be. Again, is this region only sorted? Yes. So I will take 4. I will take 4 and I will compare. Is 4 is less than 1? No, it is not, right? I have no need to update it. What I will do, I will simply move my low point. I will simply move my low point, right? And now, moving low pointer, again I will check. Low pointing to here, high pointing to here. My mid will also pointing to here. Is 5 is less than 1? 5 is less than 1? No, no need to update. So 1 will be the minimum. 1 minimum element. 1 will only be the minimum element. Now let's check the last example here. So most of the students find out this example a bit tough. Let's quickly check it. So I am getting 3, 1, 2. So here this will be my low element. This will be my high element, right? This will be my mid element, right? So is this is sorted region? No, no, this is not sorted. This is unsorted. This is the sorted. Again, right, my minimum is with plus infinity. I will update with my mid element. What is my mid element? 1. Okay, after updating it, my high pointer will be lie here. My high pointer will be lie here. So we check low and high. We check mid. Mid will also lie at 3. Is 3 is less than 1? Is 3 is less than 1? No need to update it. It will be remain 1, right? After this, your low pointer will move. You will get the condition of greater than L. You will simply eliminate. Okay. Now let's see a quick dry run of this code, and then we will see the code part. So let's quickly do a short dry run of this example. Now let's see a quick dry run of this. So here you can see my low pointer is at 0. My high pointer is at 7. What will be my mid pointer? My mid pointer will be right 0 plus 7 by 2 will be lying here, right? So it will be 3. Okay. Now what I will do, I will find the sorted region. This is sorted region. This is sorted region. No, it is not. Okay. So I will find out this is my sorted region. Yes. So I will compare my mid element with my minimum, right? Let's suppose in the initial, my minimum is with plus infinity, right? With a higher value, with more higher value. So my mid element is 2, which is much more lesser than the infinity. So my minimum will be 2. My minimum will be 2. And what will be my action? My action will be high is equal to mid minus 1. So my high pointer will lie here. Okay. Once my high point is lie here, so my low index is still 0. My high index is 2. What will be my mid? Mid will be by 1. Okay. Now my mid will be 1. Now again I will find out the sorted region. This is sorted region. 7 to 8 is this is sorted region. Yes, it is. Right. So what I will do, I will compare 7 with my minimum. Is 7 is less than minimum? Is 7 is less than minimum? No, it is not. Right. So what I will do, it will be remains 2, but my low pointer will move. My action will be low is equal to mid plus 1. Mid plus 1. So low pointer will move here. Now low mid was 1. Mid plus 1 it will be 2. High pointer is 2. Where will be my mid? It will also be 2. Mid will also be here. Right. So now what I will do, I will check what is my mid element. This is my mid element. Right. Again I will check low 2. Is this is my sorted region? Can I say this single element is my sorted region? Yes, it is. Right. So I will compare. Is 1 is less than my minimum? My current minimum? Yes, it is. 1 is less than. So I will update with. Okay, so I will update with 1. And now once it is done, what I will do, I will again do low is equal to mid plus 1. Right. So low, what is my mid? Mid is 2. Low is equal to mid plus 1. It will be 3. And high will be at 2. So here can I say low should less than equals to high? Here your low pointer is greater than your high. High low pointer is greater than high. Can I say that this will break the loop? This will break the loop. Right? This will break the loop. Once it is breaking, right? Can I say which element is the minimum element I got? This is my minimum element. So here it will break it, and the minimum element I will get here is okay. Now only one thing here, okay, that we can add here. So if the array is already sorted right here, if the array is already sorted, or if one of the region is already sorted, okay, do we really need to compare? Do we really need to find the sorted region, right? If it is already sorted, so if I am getting AR low pointer that is less than high pointer, okay, can I directly say that this will be my minimum element? This will be my minimum element, or suppose you are pointing to something. Suppose you are here, okay, you eventually come to here, right? Eventually come to here, or any region where 1 2 3, this is your low pointer. Suppose here your high pointer is here in this region, somehow came in, right? So instead of checking, right, this will be your mid. Instead of checking this sorted region, can I directly say my low point, my low element is less than my high element? Can I directly say that no point, if this is condition is true, my low point element will always be the minimum element. Can I directly say? So this is one optimization that we can optimize it, so we can save few of the iterations and we can get the time complex. We can get the solution in a much more easier way. Okay, now let's just talk about time complexity. What will be the time complexity? Again, we are applying binary search. We are binary search here. So again, the time complexity will be big O of log n base 2, right? Because how time complexity works like this is n, it will be divided into n by 2, then n by 4, and so on, n by 8. Okay, so it will be big O of log n base 2, where n is the size of the element. Okay, now let's quickly check out how we can implement this code. Let's see.